Okay, today we're going to look at Module 1, Lesson 9. So Lesson 9 should look somewhat familiar because we see here the words equivalent ratios. We've been working on equivalent ratios. What's one way that we can tell if ratios are equivalent? Alright, the first thing we could try is our double V. That's times 2, that's times 2, and so since they were both multiplied by the constant, we know they're equivalent ratios. What's another way? What was the last way that we learned? You could translate the fractions. Right, what's that word that when they're written as fractions, that's using the value. So if we had 2 to 4, 2 to 4, 1/2 is the value. Then if we had 4 to 8, that's 4/8, and the value is 1/2. So since the values are the same, then I know that those are equivalent ratios. Today we're going to continue to looking at equivalent ratios, but today we're going to use tables. Not the kind of tables you're sitting at. But I'm sure you're very familiar with tables. In fact, I think we even used tables back on Lesson 1. So let's take a look at what this means. Okay, so to make paper mache, first of all, does anybody know what paper mache is? Okay, if you're not familiar with it, paper mache is a craft project. So back in the day when I was your age, if I was learning about continents and oceans and social studies, something the teacher may have assigned was to make a paper mache model of all the continents and oceans. So what I would do is blow up a balloon, but a balloon is kind of soft. And if I start drawing on it, I might poke it. So what I would do is take the newspaper and cut it into strips. Then I'd get flour and water and mix it together. And I would take the newspaper, dip it in this paste, and put the strips all over the balloon so I covered it like a casing. But I'd leave the bottom open a teeny tiny bit. Then that paper mache, the paper with the glue on it, will dry hard. So then I could just take a needle and pop the balloon, and now I have this hard shell. Because when I was growing up, we didn't have Michael's and Joann's and all these craft stores where I could go buy a foam ball to make my project. So we would use paper mache, and that would make a nice round shell, and then I could paint it and label it. So all that to explain number 1. So the art teacher wants to use paper mache. So to make that glue mixture, she decides to mix water and flour. For every, ding, 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 when I see those words for every, what do I know is coming? Everybody? Ratio, that's my verbal cue word. So for every 2 cups of water she puts in, she needs to mix in 3 cups of flour. So what 2 things am I comparing here? What are my 2 things in my ratio?
You're comparing water and flour.
Water to flour, and what's my ratio?
2 to 3.
2 to 3. So I'm just going to put that off to the side, which you should be doing. You should have your date on the page. Okay. So we're going to find equivalent ratios for the ratio relationship 2 cups of water to 3 cups of flour. So for 2 cups of water, we have 3 cups of flour. Let's scale that up. What would be the first, the easiest, the most obvious equivalent ratio? How'd you do that? 4 cups of water to 6 cups of flour. Your constant was 2. You can multiply them both by 2. That would be enough for a bigger project. But now suppose both of my kids have to do a project. I want to make it even bigger. So what would be an equivalent ratio if I wanted to make it bigger?
8 to 9.
I could do 8 to 9. So how'd you do that?
5, 4, and 2. Wait, no.
Yeah, let's be careful. So let's go back. Let's start here. So we multiplied it by 2. So now let's multiply it by 3. So 2 times 3 is 6. 3 times 3 is 9. So now let's take the next one. Instead of multiplying it by our constant 3, let's multiply it by 4. So 2 times 4 is 3 times 4 is, and we'll do one more. 2 times 5 is 10. 3 times 5 is 15. So this table is now filled with equivalent ratios. Okay, but we wanted to see them in the order using the smallest number. So they didn't want us skipping any. Okay? So to make sure I didn't skip, I just kept multiplying by the next constant. But now I want to double check because if I use my double V method, let's take a look. I have 6 to 9 and 8 to 12. This table is telling me that they're equivalent. Does my double V method work? No. Because 6 times what is 8? I'm sure it's something, but that's way too difficult to figure out. What's my other way to see if those are equivalent? Instead of using double V, what can I use? I can use the values. So if you wanted to add on a third column to your table, let's take a look. The value of 2 to 3 is 2/3. You can add this column on. The value of 4 to 6 is 2/3. The value of 6/9 is 2/3. The value of 8/12 is 2/3. The value of 10/15 is 2/3. So now I could see that they all have the same value. They're all equivalent ratios. So I was able to use my table to find equivalent ratios. So far, so good? Yeah. We decided it. The constant can be any number we want it to be. As long as whatever we do to the first number, we do to the second number, we're in good shape. The constant can be anything. Remember this? A to B, C to D. As long as that's the constant, and that's the constant. Okay, let's take a look at example 2. Javier has a new job designing websites. He is paid at a rate of $700 for every 3 pages of web content that he builds. Create a ratio table to show the total amount of money Javier has earned in ratio to the number of pages he has built. So the table is already set up. We're comparing pages to money. So how many pages? 3. The money is 700. Can I scale that down to find out how much you would get paid per $1? Suppose I wanted to scale that down. Is that something that I could do? What would I have to do to get that down to 1? I would have to divide them both by 3. Because 3 divided by 3 is 1. So 700 divided by 3. Is that going to work evenly? I know from my divisibility rules, that's not going to work. So can I scale that down? No. That's the smallest unit that I'm going to be able to use. So now let's pick our constant of 2. So times 2 times 2 times 3 times 3 times 4 times 4 times 5 times 5 times 6 times 6 times 7 times 7 times 8 times 8. Woo! Right now, see, there's a reason he's working so hard. And there's a reason why my son just applied for his first job. Because he's saving for a car. So the car that he wants is $4,300. This is where those tables come in handy. I can look at that table, How many web pages does he have to design? Well, no, I don't know that. He's going to have to do 21. And then he'll have money left over. But if he only designs 18, he won't have enough money. 19 isn't on there, so we don't know what that would be, if that would be enough. So he would have to build 21. Now, if we started like this, because he needs $4,300, the double V wouldn't work. I don't know what that constant would be, because it's not times 6, it's not times 7, so that double V method wouldn't work to find how many web pages. So that's where making the tables really come in handy if the equivalent ratios don't work out even. Okay? So your homework is tonight, page 36, and you can actually do it right on the paper tonight.
Yeah.